When looking up at the dark sky on a clear autumn evening, a network of shining points stretches before us. These twinkling lights seem countless, but they represent only a tiny fraction of the true universe surrounding our world. With the naked eye, we can see only a few thousand of the nearest stars, all belonging to our small corner of this immense cosmic structure. The diameter of the observable universe is currently estimated to be around 93 billion light years. Within this distance that surpasses human understanding, there are at least 2 trillion galaxies, each consisting of billions of stars. Each of these galaxies is an independent cosmic city, holding its own secrets and its own stages of development. These cosmic islands are so far apart that even light takes millions of years to travel through the void between them. Our home galaxy, the Milky Way, is just a single drop in a vast ocean or a grain of sand on an endless beach. Even within the borders of our own galaxy, the number of suns is so large that it challenges our ability to process huge numbers. If someone decided to count every light source in our galaxy one by one, once per second without stopping, this task would take over 3,000 years. That counter would begin their work in the Bronze Age and finish only today, seeing the rise and fall of civilizations as mere background noise. Humanity cannot easily comprehend such immense spans of time or distance, as our individual lives are just a brief flash in the history of existence. This thought of counting stars for over 3 millennia reveals how much information and mystery our home galaxy alone contains. Let us pause for a moment in the peace of a quiet winter night, far from the lights of cities, where our breath forms a soft mist in the still air. The darkness curving above us feels almost tangible, and each tiny speck of light is a distant giant, sending its radiation through the silent void. The light reaching our eyes at this very second has traveled through space for thousands of years before ending its long run at our gaze. This realization brings humility and confusion about how small we truly are within this magnificent cosmic architecture. These large numbers and dimensions are not just cold mathematics, but they represent an almost limitless number of different possibilities. When we look at the billions of suns in the Milky Way, we can only guess how many planets circle these bright central stars. Modern science has shown that planets are not exceptions, but they are a natural result of how solar systems form and grow. Yet, each of these worlds is currently out of our reach, remaining a distant promise of something greater. This immense space stretching around us is like a giant dark room where we have lit a single tiny match. Our solar system is located in a quiet suburb of the Milky Way, far from the unstable and dangerous radiation of the crowded galactic center. This sheltered position has given life the necessary time to develop and flourish for billions of years without major cosmic disasters. But when we look out from this protected nest, we face only a cold void and a quietness that does not answer our questions. Every point of light in the night sky reminds us that we are just a tiny part of an unimaginably grand whole. With so many suns and systems out there, we are forced to wonder why we are here and why we see no signs of others. The infinite emptiness of space seems to offer only a complete, unbroken silence in return. For a long time, humanity could only speculate whether other suns held their own families of planets. Modern astronomy has finally lifted this veil of ignorance, revealing that planets are a common feature of the cosmos rather than a rare anomaly. Today we know that nearly every light in the night sky has its own orbiting companions dancing in their own intricate cosmic waltzes. This search has revealed a surprising diversity of environments, challenging what we once thought possible for solar systems. Some of these distant spheres are puffy gas giants, cold and massive, while others are rocky worlds with solid, defined surfaces. We have found worlds where the clouds rain molten iron, and others covered completely in layers of ice hundreds of kilometers thick. Among all these discoveries, the most exciting targets are those rocky planets orbiting within what scientists call the habitable zone. This region is often compared to a cosmic cradle, where the distance from the host star is just right for liquid water to exist. If a planet is too close to its sun, the water boils away into steam. If it is too far, it freezes into eternal ice. Water is the universal solvent of life as we know it, acting as the essential medium where complex organic chemistry can begin. Estimates suggest that our galaxy alone contains tens of billions of rocky planets located within these temperate zones. That means there are billions of potential cradles waiting in the dark, each with a chance to develop its own unique history. We can picture a silent observer standing on the rocky shore of one of these distant, untouched worlds under the light of a dim red sun. The air is completely still, and the sky is filled with unfamiliar colors as the host star slowly sinks below the horizon. A gentle breeze carries the scent of minerals, and the only sound is the rhythmic washing of waves against dark basalt rocks. These untouched spheres wait in the deep quiet of space, untouched by human footsteps and unrecorded by our history. Many of these worlds may not just have small lakes, but they could harbor vast global oceans that cover their entire surfaces. Underneath thick shells of steam or ice, these liquid reservoirs represent vast chemical laboratories where nature can experiment with the building blocks of biology. On our own planet, life did not begin on the dry land, but in the dark, warm depths of the primordial ocean. Deep-sea hydrothermal vents provided the energy and chemistry needed for the very first cells to organize themselves. If the same processes occur elsewhere, then these distant hidden oceans could already be teeming with microscopic alien life. With tens of billions of potential habitats, the opportunity for life to find a way seems almost guaranteed somewhere in the dark. Yet, as we look closer at these promising candidates, we are met with the same unchanging reality that defines our search. These beautiful watery worlds remain completely silent, leaving us to wonder if they are indeed alive or merely empty monuments of stone and water. When we look at the sheer number of possible worlds, the laws of probability present us with a startling conclusion. If even a tiny fraction of those tens of billions of temperate spheres develop the simplest form of life, biology should be common. Over immense stretches of time, some of these living ecosystems would inevitably evolve toward intelligence and technology. Our galaxy should not be a quiet desert, but rather a crowded forest teeming with active civilizations. Advanced technological communities would naturally leak radio waves, television signals, and radar pulses into the surrounding vacuum. More mature builders might construct massive engineering projects, reshaping entire star systems to capture light and power. Their spacecraft would travel between suns, leaving glowing exhaust trails and communication networks that we could easily detect. Even a single ancient civilization could have spread its presence across every corner of the Milky Way by now. Yet, when we point our most sensitive listening devices toward the sky, the cosmos offers no such greetings. Let us step inside a modern radio observatory in the middle of a barren desert, where the giant metal dishes point silently toward the stars. Inside the control room, the only sound is the quiet hum of cooling systems, keeping the advanced sensors near absolute zero. On the screens, wavelines wiggle back and forth, translating the raw cosmic radiation into visual data. We put on headphones and listen to the audio feed, expecting perhaps a rhythmic pulse or a repeating pattern of artificial code. Instead, we are met with nothing but flat, chaotic static, the cold background hiss left over from the birth of the universe. We hear and see absolutely nothing that suggests the presence of another mind in the dark. The universe appears to be a vast, empty mansion, with all the lights turned off and no one home. We walk through its dusty corridors, looking into room after room of beautiful stars and planets, but finding only empty chairs. This deep discrepancy between what we mathematically expect and what we actually observe is a jarring riddle. For over 60 years, we have searched the heavens with increasingly powerful tools, hoping for a single whisper. We have scanned millions of frequencies and examined thousands of star systems, yet the results remain completely negative. No alien structures block the light of distant stars, and no glowing fleets move between the worlds. This total lack of evidence makes us question our basic assumptions about how a technological civilization behaves. The silence itself becomes a powerful piece of data, suggesting that some hidden law or barrier is at work. It raises the profound question of why we are so utterly alone in a cosmos that has all the ingredients for life. This unbroken quiet forces us to face the possibility that our existence is far more unusual than we ever dared to believe. To understand why the silence is so puzzling, we must look at the history of our universe through a different lens. The cosmos is nearly 14 billion years old, while our own solar system was born only 4.5 billion years ago. This means that for billions of years before Earth even existed, the galaxy was already mature and stable. Generations of stars lived, burned, and died, spreading heavy elements throughout the dark to form rocky planets. Let us compress this entire history into a single cosmic calendar, where the Big Bang occurs on the first second of January. In this vast chronology, our solar system does not appear until late August, showing how late we are to the scene. The first simple life on Earth begins to stir in the oceans during September, slowly developing over the autumn months. Dinosaurs rule the planet for a few days in late December, disappearing on the 30th day of that final month. Human history, from our earliest ancestors to the modern age, occupies only the final seconds of the last day before midnight. Our entire written record, all our victories, struggles, and technological progress, fits into the last single second of the year. This perspective shows that we are extreme newcomers, arriving at a party that has been going on for a very long time. In those aeons before our arrival, other technological societies could have emerged on ancient planets. A species that appeared even 1% earlier than us would have a head start of over 100 million years. Imagine what humanity could achieve with that amount of time, considering how far we have come in just a few centuries. We went from riding horses to walking on the moon in less than 100 years. With millions of years at their disposal, an early society would easily master interstellar travel and cosmic engineering. Using even slow, self-replicating robotic probes, they could map and colonize every star system in the Milky Way within a few million years. They could have completed this monumental task multiple times over, reshaping the galaxy long before we took our first steps. The vast gap between our youth and the age of the cosmos is what makes the silence so difficult to explain. We should find the galaxy filled with ancient relics, abandoned beacons, and colossal structures orbiting dead stars. Yet, our sensors detect no shadows of past greatness, and no ancient signals wash over our world from the deep void. The universe remains completely clean of any past footprints, as if we are the very first to ever walk these halls. This reality leaves us with a choice between two equally unsettling possibilities about our place in the cosmic chronology. In the summer of 1950, a group of brilliant scientists walked to lunch at the Los Alamos National Laboratory in New Mexico. They were chatting casually about a recent cartoon in the newspapers, laughing at drawings of flying saucers and alien visitors. Among them was Enrico Fermi, a legendary Italian-American physicist famous for his incredible intuition and sharp mind. As they sat down at the table, surrounded by the clatter of plates and the quiet hum of the cafeteria, Fermi fell silent for a moment. He was calculating numbers in his head, estimating the size of the galaxy, the speed of rockets, and the age of stars. Out of nowhere, he looked up at his colleagues and asked a simple, sudden question. Where is everybody? The table went quiet as the other scientists realized the deep truth hiding behind those three simple words. This casual lunchtime question would define one of the most famous scientific puzzles of our time, the Fermi Paradox. It is not a strict mathematical paradox, but rather a deep, irritating contradiction between what we expect and what we see. On one hand, our equations say the night sky should be teeming with active communities and technological signals. On the other hand, we face a silent, dark void that offers absolutely no evidence of anyone else, creating an intellectual puzzle. As our astronomical tools and knowledge grow, this mystery of the cosmic silence becomes increasingly difficult to solve. We are no longer guessing in the dark, but instead measuring the universe with incredible precision. When Fermi asked his question, we did not know for sure if a single planet existed outside our own solar system. Today, our space telescopes have confirmed thousands of exoplanets orbiting distant suns, revealing that planetary systems are everywhere. This explosion of knowledge acts like a heavy weight on the cosmic scale of balance, tipping it further toward the inevitability of life. Yet, even as we find more and more perfect rocky worlds, the silence around us only seems to grow deeper and more terrifying. Every new discovery of a habitable world is a double-edged sword, bringing both hope and a growing sense of isolation. We are listening with the most advanced radio telescopes, scanning the sky for any faint whisper or stray transmission. We have built massive arrays of dishes in remote deserts, yet they record nothing but the cold background hum of dead space. This silence is the core of the Fermi Paradox, an uncomfortable truth that challenges our place in the cosmic hierarchy. We cannot easily dismiss the problem as a lack of technology on our part, because our listening methods are now incredibly sensitive. We are forced to ask if we are somehow special, or if there is some hidden danger that destroys civilizations before they can reach out. The more we learn about the friendly conditions of the cosmos, the more confusing this lack of contact becomes. The question asked over a simple lunch in New Mexico remains unanswered, hanging over our modern scientific efforts like a dark cloud. In the late autumn of 1961, a young astronomer named Frank Drake stood before a green blackboard in Greenbank, West Virginia. The air in the room was cool, and the scent of chalk dust hung quietly as he held a piece of white chalk in his hand. He was preparing for the first scientific meeting on the search for extraterrestrial intelligence, looking for a way to structure the discussion. Slowly and deliberately, he wrote down the series of 7 mathematical symbols, connecting them with simple multiplication signs. As the chalk scratched against the slate, he had no idea he was creating one of the most famous formulas in scientific history. This simple string of symbols would become known as the Drake equation, a tool designed to estimate the number of active mines in the Milky Way. Rather than solving the mystery directly, this mathematical roadmap breaks a massive, overwhelming question into smaller, manageable pieces. It acts like a cosmic recipe, listing the essential ingredients that must come together for a technological culture to exist. The first factors are purely astronomical, looking at the rate of star formation and the fraction of those suns that have planets. The most mysterious and critical factor is the very last one, the average lifespan of a technologically advanced society. This variable is like the final link in a long chain, and if it is fragile, the entire structure falls apart. If advanced cultures destroy themselves quickly after inventing radio communication, then the galaxy remains empty. Because we do not know the exact values for most of these factors, the results of the formula vary wildly depending on our choices. An optimistic calculation can suggest that there are millions of thriving cultures scattered across the stars at this very moment. A pessimistic view, using very conservative numbers, suggests that the final result is exactly 1, meaning we are completely alone. The true power of the Drake equation does not lie in its ability to give us a single, perfect answer. Instead, it serves as a vital framework that organizes our scientific ignorance, showing us exactly where we need to look. Over the last 60 years, astronomy has successfully solved several of the first cosmic ingredients on the blackboard. We now know for sure that planets are incredibly common, but the biological and technological factors remain complete mysteries. Until we find a way to measure the lifespan of technological societies, the final result will remain a matter of debate. This mathematical equation continues to guide our efforts, reminding us of the high barriers that life must overcome to survive. Each symbol is a door we must open, and so far we have only managed to peek through the very first few. In 1964, Soviet astronomer Nikolai Kardashev proposed a revolutionary way to think about the future of intelligence. Instead of classifying societies by their politics or culture, he created a metric based purely on their energy consumption. He realized that as a technological species grows, its hunger for power must eventually expand beyond its home world. This system, known as the Kardashev scale, divides advanced cultures into 3 distinct levels, like steps on a cosmic ladder. A Type 1 civilization is planetary, having mastered all the energy resources available on its home sphere. Such a society would control the weather, harvest all sunlight hitting the surface, and utilize the full power of geothermal energy. Currently, humanity has not yet reached this first step, consuming only a tiny fraction of our planet's total energy potential. A Type 2 society is stellar, capable of capturing and utilizing the entire energy output of its host star. To achieve this, the builders would construct a vast swarm of collectors, a Dyson sphere, enclosing the star like a protective cocoon. Let us drift silently in the deep void of space, looking back at a star that has been completely enclosed by this cosmic machinery. From a distance, the star no longer shines with visible light, having disappeared from the eyes of the universe. Inside this massive shell, trillions of collectors capture every single photon, feeding a network of energy that powers a virtual world. The sheer scale of this construct is beyond human imagination, making our largest cities look like microscopic dust specks. A Type 3 society is galactic, controlling and manipulating the energy of billions of stars across its entire home galaxy. Such a legendary civilization would be able to reshape entire star systems, moving planets and tapping into the power of black holes. They would communicate instantaneously across vast distances, managing their cosmic empire as easily as we manage a single city. If a galactic society existed in the Milky Way, its presence would be impossible to hide from our telescopes. A galactic empire would alter the light of its home galaxy, leaving a massive, unmistakable footprint in the infrared spectrum. Yet, when astronomers scan the heavens for these massive energy signatures, the results are completely blank on every level. Our observations have scanned hundreds of nearby galaxies, yet each one appears to be completely wild and unshaped by technology. We find no infrared cocoons around nearby stars, and no distant galaxies show signs of being managed by Type 3 builders. This total absence of megastructures suggests that very few, if any, technological species ever reach these advanced levels. It highlights our own youth and fragility, showing how far we have to go before we can even climb the first step of this cosmic scale. Perhaps the barriers on the cosmic path are far higher than Kardashev ever imagined, keeping every voice small and isolated in the dark. When we think about traveling between stars, our minds naturally focus on the immense, crushing distances of the dark void. Yet, mathematical models suggest that colonizing the entire Milky Way would take only about 2 million years using very slow, conservative technology. While 2 million years feels like an eternity to human history, in cosmic terms, it is a mere blink of an eye. It represents less than 1/10 of 1% of our galaxy's total age, making galactic migration a surprisingly fast process. This expansion would not require science fiction technologies like warp drives or faster-than-light travel. Instead, a species could build massive generation ships, where thousands of people live, work, and die inside closed steel worlds. Let us step inside one of these giant vessels, floating silently in the eternal night between the stars. Inside, there are simulated forests, small towns, and artificial rivers, all powered by a quiet nuclear fusion core at the center. For centuries, generations are born and buried without ever seeing a real sun or feeling the gravity of a natural planet. To them, this steel island is the only world that exists, a tiny bubble of life traveling through a frozen, indifferent ocean. After several hundred years of slow cruising, the vessel finally arrives at its target star, establishing a new home. Once the new settlement is stable, it builds its own ships, spreading further outward like ripples on the surface of a quiet pond. This exponential growth means that the wave of colonization moves across the galaxy at a steady, unstoppable pace. Within a few million years, every single star system would have its own outposts, habitats, and listening stations. Since the galaxy has been hospitable for billions of years, this process could have happened hundreds of times before we appeared. If even one ancient species had decided to colonize the stars, their descendants should be everywhere around us today. They should have settled in our own solar system, mining the asteroid belt and leaving ancient monuments on the moon. Yet, when we look at our neighborhood, we find no orbital habitats, no industrial scars on Mars, and no alien artifacts. We see no planetary systems that have been reshaped, and no star systems that show signs of galactic engineering. This total lack of presence suggests that something incredibly powerful prevents this outward movement from occurring. Immense invisible barriers must block the path of technological species, stopping them before they can spread across the stars. These limits could be physical, biological, or even psychological, forcing every culture to remain in its cradle. Perhaps there is a universal law of nature that makes long-term galactic survival far more difficult than our simple mathematics suggest. Our plans to settle other worlds are still in their infancy, but the silence of the sky suggests we may be heading toward a wall. We are left looking at an empty sky, wondering which of these invisible barriers will determine our own future. To resolve the mystery of the empty sky, scientists have proposed a concept known as the Great Filter. This hypothesis suggests that along the path from dead chemistry to a galactic empire, there is a barrier so difficult that almost no one can pass. This choke point acts like a giant cosmic sieve, sorting out millions of potential worlds and leaving them completely barren. This evolutionary barrier must lie either in our past, meaning we have already crossed it, or in our future, waiting to destroy us. If this monumental choke point is behind us, it means that the development of intelligent life is an incredibly rare miracle. The very first step, the transition from raw organic chemicals to the first self-replicating organism, could be the main barrier. It is possible that the spark of life is a chemical lottery with odds of 1 in trillions, occurring on Earth by pure luck. Let us travel back in our minds to our own planet 3 billion years ago, a violent world of boiling oceans and poisonous skies. Underneath the turbulent water, hydrothermal vents spew hot, mineral-rich fluids into the crushing darkness of the ocean floor. Here, in this chaotic environment, simple single-celled organisms have ruled supreme for over 1 billion years without changing. Then, an event of pure chance occurs. One simple cell swallows another, but instead of digesting it, they form a permanent partnership. This single, incredibly lucky merger creates the first complex cell, unlocking the potential for all multi-celled life to evolve. On Earth, this leap from simple bacteria to complex cells took nearly 2 billion years, half the age of our planet. This long delay suggests that the step is an incredibly high biological bottleneck, one that most living worlds never manage to cross. On millions of other planets, life may remain forever stuck in this simple, single-celled stage, never developing beyond microscopic blobs. Even after complex life develops, the road to high intelligence requires a very specific set of biological and social circumstances. Dinosaurs ruled our world for over 150 million years without ever building a single radio transmitter. Large brains are extremely expensive in terms of energy, and evolution does not favor them unless the environmental pressure is perfect. A species must develop not just intelligence, but also vocal cords for language, hands for tool use, and complex social structures. If any of these evolutionary steps act as the great filter, then the universe is indeed a quiet, empty place. Billions of watery worlds may be filled with nothing but simple green slime, unable to ever take the leap toward complex intelligence. If we are the only ones to have successfully crossed this biological filter, our existence is a monumental achievement. Our planet would be a rare beacon of light in an otherwise dark and sleeping galaxy, a unique experiment that succeeded. We would be the sole guardians of consciousness in our galaxy, carrying a victory that is as precious as it is lonely. But there is a far more terrifying alternative to the idea of a rare and miraculous past. If the great filter lies in our future, it means that life is common, but advanced societies inevitably hit a wall. This dark perspective suggests that almost every technological species is doomed to destroy itself before it can escape its home star. The window between discovering radio waves and total self-destruction might be incredibly narrow, perhaps only a few centuries long. As a species gains the power to manipulate nature on a grand scale, its capacity for destruction grows faster than its wisdom. We developed nuclear weapons only a few decades after industrialization, placing the key to our own doom in our hands. Industrial progress can also lead to runaway climate change, ecological collapse, or the total exhaustion of essential planetary resources. A global society can collapse under the weight of its own complexity, reverting to a primitive state from which it can never recover. In our modern age, we face new, unpredictable threats like uncontrolled artificial intelligence, which could easily outcompete and replace its creators. It is possible that some promising new scientific discovery, perhaps in particle physics or energy generation, acts as a hidden trap. A brilliant researcher in a distant world might turn on a revolutionary machine, only to trigger a chain reaction that vaporizes the planet. Let us walk through the silent, dusty streets of a dead alien city on a world where the filter was triggered. Towering structures of glass and steel still reach toward the sky, but they are completely empty and dark. The wind is the only force moving through the abandoned plazas, blowing red dust across roads where no one has walked for 1,000,000 years. There are no bodies, no ruins of war, just a silent tomb of a society that solved its energy problems but forgot how to survive. In addition to self-destruction, the cosmos itself is a violent environment that regularly sterilizes entire regions of space. Stellar explosions, gamma-ray bursts, and stray asteroids act like cosmic furnaces, wiping out promising worlds without warning. These energetic bursts can strip a planet's atmosphere in a matter of seconds, turning a blue paradise into a sterile desert. A planet might develop complex life over billions of years, only to be washed in deadly radiation from a nearby dying star. If these external and internal threats are indeed a universal law, our own future is in extreme danger. We are currently sailing through the most dangerous part of our development, trying to cross the filter that has killed so many others. This dark realization forces us to think about our destiny with a deep sense of responsibility and extreme caution. Our technological power has grown exponentially, but our political and social wisdom remains stuck in the past. Every technological decision we make in the coming years will either help us climb over this wall or push us into the abyss. If we cannot find a way to balance our power with wisdom, we will simply become another silent statistic in the empty sky. If the silence is not caused by the complete absence of life, then we must consider another intriguing possibility. In 1973, astronomer John Ball proposed an explanation known today as the zoo hypothesis. This idea suggests that advanced species are indeed out there, but they have deliberately agreed to avoid any direct contact with us. To them, our planet is like a protected cosmic nature preserve, a sanctuary where a young species is allowed to develop naturally. We are being watched from behind a cosmic glass wall, studied by a silent audience that chooses not to interfere in our affairs. They might observe our progress secretly, using monitoring technologies that are completely invisible to our current instruments. Let us imagine a silent organic probe floating in the cold shadow of the moon, completely disguised as a dark asteroid. Its advanced sensors, operating on physical principles we have not yet discovered, monitor the radio waves leaking from Earth. On its screens, the night side of our planet glows with the artificial light of thousands of growing cities, like a network of fireflies. The probe records our wars, our music, our scientific discoveries, sending this data back to a distant galactic network. Yet, it never sends a signal back, maintaining its perfect disguise to ensure we never suspect we are being tracked. This deliberate silence is not cruel, but rather a protective measure designed to shield our culture from shock. Our own history on Earth shows that when an advanced technology encounters a less developed one, the results are often devastating. The weaker culture is quickly overwhelmed, losing its identity, its social structure, and its independent path of development. To prevent this cultural collapse, the older minds of the cosmos might treat us like fragile children, watching us from a safe distance. We must show that we are capable of managing our power wisely, moving past our primitive tribal conflicts. They will only step forward and reveal themselves once we have reached a certain level of intellectual and ethical maturity. This threshold might require us to prove we can live peacefully without destroying our homeworld or ourselves with nuclear weapons. The zoo hypothesis paints a much friendlier picture of the cosmos, suggesting that we are not abandoned, but protected. However, this theory relies on the assumption that every single advanced culture in the galaxy agrees to follow the same rule. It would take only a single rogue group or rebellious explorer to break the quarantine and send us a direct message. Maintaining a perfect cosmic quarantine across billions of star systems for thousands of years seems incredibly difficult to enforce. Our instruments will continue to search for any small crack in their glass wall, hoping to catch a stray whisper that was not meant for us. Until a visitor decides to break that quarantine, we must continue to live inside our silent cage, looking out at a sky that watches us in secret. While hypotheses like the zoo theory offer comforting scenarios of silent protectors, we must also face a much colder possibility: the rare earth. Hypothesis suggests that the conditions required for complex, intelligent life to emerge are so rare that we might be completely alone. It is easy to assume that any rocky planet with water can support life, but the list of necessary cosmic coincidences is incredibly long. We exist in a very narrow galactic habitable zone, far from the deadly radiation of the core and the metal-poor regions of the outer rim. Our solar system is blessed with a giant gas planet, Jupiter, whose massive gravity acts as a cosmic shield, vacuuming up dangerous comets and asteroids. Without this giant protector, Earth would be bombarded by devastating impacts every few 100,000 years, preventing complex life from ever settling down. We also possess an unusually large moon, which stabilizes our planet's tilt and keeps our climate stable over hundreds of millions of years. Without the moon's steadying grip, Earth's poles would tilt wildly, causing extreme weather shifts that would freeze or boil the surface repeatedly. Even our plate tectonics and strong magnetic field are essential, protecting our atmosphere from being stripped away by the harsh solar wind. If any of these factors were missing, our blue world would be as dead and dusty as Mars or Venus. Let us stand on a quiet hill in the Finnish countryside, looking up at the ribbon of the Milky Way stretching across the sky. The night air is crisp, and the scent of damp moss and pine needles rises from the dark ground beneath our feet. There are no sounds of technology here, only the gentle whisper of the wind through the treetops and the absolute quiet of the cosmos. We look out at those billions of distant stars, realizing that each one might be a beautiful silent monument of ice and rock, completely devoid of thought. If we are truly the only conscious minds in this vast space, our perspective on the cosmos must change completely. Humanity carries an unimaginably massive cosmic responsibility for the survival of consciousness. We cannot expect any rescue, guidance, or salvation from the outside, because there is no one out there to hear our cries. If we destroy ourselves through war, neglect, or technological hubris, the spark of intelligence in our galaxy will simply go out. The universe would return to a cold, unobserved state, with no one to admire its beauty or understand its complex laws. We are, quite literally, the universe's way of thinking, feeling, and understanding itself. Our telescopes and minds are the eyes and brains of the cosmos, translating raw physics into meaning and wonder. Every decision we make on our small home planet determines whether this fragile flame of awareness will grow or be extinguished forever. This realization makes our internal conflicts look incredibly small and foolish in the grand scheme of time. We must protect our homeworld and each other with a deep sense of shared destiny and unwavering caution. The riddle of the silent sky is not just a scientific puzzle, but a mirror reflecting our own vulnerability. As we look forward into the great unknown, we must carry our light carefully into the dark, knowing we are the only ones holding the torch.